Hello and welcome back. Today we'll get into section 5.1 on composite functions. So composite functions, you need at least two different functions. 3x minus 5. Well, you could have one repeated function as well. It's easier to see what's going on with two though. So just like if I was asked to find f of -2, that would just tell me, okay, which of these guys am I working with? I'm working with this one. And it says take 3 times your input and subtract 5 from it. Only this time now my input is a -2. And then just we simplify where we can. So that would be worth a -11. Well, occasionally we're asked to find things like f of g of x. Same exact idea. Take function f, which is 3 times something minus 5, and plug in whatever's in here. In this case, it just happens to be g of x, which is a 4x plus 4. Now, this is one way that compositions are written. Another way is with the circle. You'll see both used. I think that this one is a little more useful. I think that this one is a little more commonly used, though. But they are both used pretty frequently. So 12x plus 12 minus 5. So we're just simplifying where we can. So just knock down those parentheses. So an f of g of x would be 12x plus 7. Now we can plug in the other way. They could ask us for g of f of x. So this says take the framework of function g, 4 times something plus 4, and plug in the 3x minus 5. So g of f of x be 12x minus 20 plus 4. So g of f of x, 12x minus 16. So one important thing to note, this is not a commutative operation. The order does matter. And yes, you can plug a function into itself. F of x says keep the framework of f, 3 times something minus 5, and plug in another 3x minus 5. So that would be 9x minus 15 minus 5. So f of x would be a 9x minus 20. Now, occasionally we get to play with rational functions in composition. So we might have f of x is 3 minus 2x over x plus 5, and g of x is the reciprocal of x minus 5. Now they could ask us for, let's do g of f of x on this one, and we'll talk about domain restrictions. So two numbers are out of our domain right away, -5 and +5, because we're working with f and g. So our domain, set of all x such that x is in the set of reals. X can't be -5 because of f. X can't be +5 because of g. And then we'll see if we have any additional restrictions when we're done simplifying g of f of x. So g of f of x says, okay, keep the framework of g. 1 divided by something minus 5. Our something this time happens to also be a fraction. 3 minus 2x over x plus 5. So we have a fraction within a fraction. we want to simplify that. We can't just leave that there. So what we'll do is we'll multiply the top and the bottom by the x plus 5. That way we're multiplying by something worth 1. We're changing the look, but not the value. And we've already established that x isn't a negative 5, so we're not multiplying by 0 over 0. So g of f of x. Upstairs is now an x plus 5. Downstairs we distribute. So I have 3 minus 2x by x plus 5 over x plus 5. So that brought it to this first of the two terms. Don't forget we have to distribute it to the second one as well. So then minus 5 times the quantity x plus 5. There's some nice little cancellation happening there. That's why we use the x plus 5. So now we can say g of f of x. Upstairs is still just an x plus 5. Denominator, now we have a 3 minus 2x. And I'll go ahead and distribute the negative 5. So minus 5x and minus 25. So g of f of x is worth, hang on to our x plus 5 upstairs. And then in our denominator, negative 2x minus 5x, negative 7x, and 3 minus 25 is negative 22. So we have one more number to throw out of our domain. X can't be negative 22 over 7. So negative by a negative would kick us over a positive. The 7s would drop. 22 minus 22 would make us divide by 0. And then we close our brace on the domain. So occasionally they'll show us a function and ask us to write it in terms of compositions. So in other words, breaking apart, undoing what we just did. So cap h of x, x to the 7th minus 3 raised to the 200th power. So it looks like I plugged in an x to the 7th minus 3. So if I want this, we'll do the form f of g of x. So g of x is the one we plugged in. We plugged in x to the 7th minus 3. That's our g of x. We plugged it into f of x, and this only got plugged in one spot, so I'm only going to put an x in one spot, and then it was raised to the 200th. So see if you can come up with a similar one for cap g of x is worth the cube root of x to the 4th minus 10x. So go ahead and pause it, see if you can come up with an f and a g, where f of g of x gives you cap g of x. Okay, welcome back. So the thing we plugged in looks like to be to me to be x to the 4th minus 10x, so that will be our g of x. So f of x, the framework looks like it was the cube root of that thing. So cube root of x. Okay, so 5-1, nice, short, quick section. And let's see, so we'll try out 138 all, 9 to 59 on the odds, and 65. I'll try to make an equivalent one for my MATLAB fans. If you have any questions, please get in touch. Otherwise, I will see you next time.